Hello friends, now we'll see how to derive transfer function from a given state model. So this is the problem, find transfer function of a system model given below. So system model is represented in this way, x dot equals to matrix A is 0 1 minus 4 minus 7 into x plus B is 0 1 into u, and output y is given in this form, y is equals to c into x. So c is 3 into x. So this is output equation and this is state equation. So model is given in this form. So first of all we need to identify whether this model is for multiple input multiple output system or this is for single input single output system. It can be easily find out using by observing the output equation. So if I observe the output equation, this equation it is in the form of c into x. So the given model is single input single output system because the next part of output equation is absent, that is d into u. So here d is equals to 0, so that means this model is for single input single output system. So from the given model we can have this matrix. We will take matrix A, that is called as a system matrix, 0 1 minus 4 minus 7. Matrix B is given like this, 0 1, C is given in this way, 2 3. Now we know this is single input single output system, so we can find out using the formula. This is the formula to calculate the transfer function of the system single input single output system. Y of s by u of s equals to c into si minus a inverse into b, or you can rearrange or we can write equation in this way: c is equals to adjoint of si minus a by determinant of si minus a into b. So this is the formula and we have to calculate all those quantity and we have to put in the formula, and hence we can have the transfer function. So we'll try to find out one by one. So si minus a, so s is the scalar Laplace operator, I is the identity matrix, minus a is the system matrix. So if I put in this way s, so we have to take identity matrix which is of the same size that of A. So this A is 2 by 2, so identity matrix is also 2 by 2. So if I multiply with S, it is going to be S0 0 S minus the matrix A. If I do it, we can have the Si minus A. So the matrix Si minus A is S minus 1 4 and last element is S minus minus plus S plus 7. So this is matrix A. So we have to find out Si minus A inverse first, and then we will put in the formula. So calculating Si minus A inverse means we need to calculate adjoint matrix first and then we have to take the determinant. So as we know how to find out adjoint matrix, so adjoint matrix can be find out. First of all we need to find out cofactor matrix, and by taking the transpose of cofactor matrix, that is called as adjoint matrix. So now we will try to see how cofactor matrix can be written. So cofactor of the first element 1 comma 1 is the even number, so the cofactor is s plus 7 which is positive, there is no sign change. So cofactor at 1 comma 2 which is odd number, so it's 4, so we have to change the sign, so that is minus 4. So cofactor at 2 comma 1, again it is odd number, so we have to take cofactor is minus of minus 1, it is going to be plus 1. So cofactor at s plus 7 is 2 comma 2, that is even number, so cofactor is yes, there is no change in sign. So this is called as cofactor matrix. Now we have to take its transpose, that will become the adjoint matrix. So if I take the transpose to first s plus 7 minus 4 1 and s, this is called as adjoint matrix. So we have to change it rows by column and column by rows. So this is called as adjoint matrix. Now we have to take the determinant of this Si minus A. So if I find the determinant, so s into s plus 7 minus 1 into minus 1, so minus minus plus, so 1 into 4 is 4, so s into s plus 7 plus 4. So if I solve this bracket, we can get s square plus 7s plus 4. This is the determinant of Si minus A, so it is going to be a denominator of your system. Now we will put everything into the formula, this formula, and hence we can have the equation like this. So this is my C 2 comma 3, this is my adjoint of Si minus A, and this is matrix B, and this is denominator a square plus 7 plus 4, that is determinant of Si minus A. So if I solve, first of all we solve A in adjoint of Si minus A into B. So if I multiply these two matrices, it is going to be S plus 7 into 0, 1 into 1, so first element will be 1, and minus 4 into 0, 0, plus S into 1 is S, so 1S. So the multiplication of these two terms is in a simple vector of having one column and two rows, 1S. Now we have to multiply with 2 comma 3. So if I multiply with, so 2 into 1 2 plus 3 into S, so 2 plus 3S is the numerator and denominator is square plus 7S. So hence this is the required transfer function, or this is the derivation of a transfer function from the state model. So y of s by u of s is equals to 3s plus 2 divided by s square plus 7s plus 4. This is the way how we can find out the transfer function from the given state space model. Thank you.